today's goal of this lecture. Today I will see some question of functional several variable based on continuity, differentiability, directional derivative, which had come in different type of GATE exam. In my previous video I had seen again and again that this type of topic actually very important for higher study, also for all competitive exam. So as a review, I had defined 3 videos on functional several variable. But at first I will highly recommend you please see my previous video of functional several variable. If you don't see, I have given the link in my description box. In my previous video, I have defined functional several variable with theorem and exercise. These 3 videos actually just as a review. Okay? So at first see my previous video of functional several variable. I have given the link in my description box. Okay? Let's see the first question. First question, which had come GATE 2017 MA exam. The question is f defined from R2 to R defined by f of xy equal to sine y square divided by x times square root of x square plus y square if x not equal to 0. That means when x not equal to 0, then the value of the function is this. Here the function from R2 to R, and when x equal to 0, then the value of the function is 0. Then at the point 0, 0, f is continuous and directional derivative of f does not exist in some direction. Option 2, f is not continuous and directional derivative exists in all direction. Here indicate directional derivative does not exist only in some direction, and in the second option indicate directional derivative exists in all direction. And option 3, f is not differentiable and directional derivative of exists in all direction, and option 4 imply f is differentiable. For this type of question, at first check continuity. Here we can check continuity. Since this is the square root of x square plus y square, we can check continuity by polar form or consider the path y equal to mx. But if we consider the polar from x equal to r cos theta, y equal to r sin theta, since here square root of x square plus y square, then this value would be r. So I hope if you consider the polar from this, then this would be more easy. For you put x equal to r cos theta and y equal to r sin theta, then after putting this value would be f of r comma theta sin r square sin square theta divided by r cos theta times r, and limit r goes to 0, this value would be r times sin r square sin square theta divided by r cos theta. So this value would be, here would be r. Since this is the bounded part, so this value would be less than equal to 1. So this value always goes to 0. So since this value is finite, limiting value is finite, so obviously f is continuous. That means I have seen f is continuous. Now we have to find the directional derivative. Since this is the polynomial function, so obviously this function is differentiable when x not equal to 0. Only we cannot tell about differentiability at the point x equal to 0. It may be differentiable or it may not be differentiable. When differentiable, we all of us know differentiable means all directional derivative exist. So at first check differentiability at the point 0, 0 because otherwise the function is, we all of us know what differentiability at 0, 0 is. Limit h goes to 0 and k goes to 0, f of hk minus h fx minus k f of y divided by square root of h square plus k square. If this limiting value tends to 0, then we can tell f is differentiable at the point 0, 0. For at first we have to find the partial derivative, and partial derivative f of y equal to limit k goes to 0 f of 0 comma y minus f of 0 0 divided by, sorry, here 0 comma k minus f of 0 0 divided by k, and f of 0 k means limit k goes to 0 sine k square over 0 times square root of k square divided by k, and obviously this value does not exist. Since this value does not exist, since partial derivative with respect to y does not exist, so we can tell function is not differentiable at 0, 0. I hope my all viewers have understood. Since partial derivative with respect to y does not exist, so function is not differentiable at 0, 0. Therefore, we cannot tell about the directional derivative. It may be exist or it may not be exist. Just check directional derivative at the point 0, 0. For directional derivative at 0, 0 means limit h goes to 0 f of h u1 comma h u2 minus f of 0, 0 divided by h, and this value is limit h goes to 0 sine h square u2 square divided by h u1 times h u1 square plus u2 square divided by h. Just cancel this part. Cancel this also, this value is h. So limit h goes to 0 sine h u2 square divided by u1 square root of u1 square plus u2 square. And since limit h goes to 0, so this value is 0. 0 times this value always tends to 0, which is finite. Since limiting value is finite, so we can tell obviously directional derivative at 0, 0 always exists. Now let's see the option. First option, f is continuous and directional derivative does not exist in some direction. This is wrong option because at the point 0, 0 function is not differentiable, but otherwise the function always differentiable. So direction also I have seen directional derivative at the point 0, 0 always exists. So directional derivative always exists in all direction. Option 2 imply f is not continuous. This is also wrong option. Option 3 imply f is not differentiable and directional derivative of f exists in all direction. So, and option 4, f is differentiable. So 1, 2, 4, this is wrong option, only option 3 is right. I hope my all viewers have understood this example clearly. Okay. Next example, who is at come? GATE 2019 exam. The question is f from R2 to R defined by f of xy equal to x square plus y square sine 1 over x square plus y square if xy not equal to 0, 0 and 0 when xy equal to 0, 0, 0. Then consider the following statement. The partial derivative del f del x and del f del y exist at 0, 0 but unbounded in a neighborhood at 0, 0. Option 2, f is continuous but not differentiable at 0, 0. Option 3, f is not continuous, and option 4, f is differentiable. At first check continuity. For this type of function, putting the polar coordinate, this is the easiest method. I hope my all viewers have understood. Put x equal to r cos theta, y equal to r sin theta. Then this reduces f of r theta equal to r square sin 1 over r square. Obviously, this is bounded function. So, when f of r theta as r tends to 0, these values, since this is the bounded function, so this limit always would be 0, tends to 0. So, f is a continuous function. So, option 2 is right, f is continuous. For differentiability, here also the question about partial derivative. For differentiability, at first use the partial derivative fx equal to limit h tends to 0 f of h0 minus f of 0 over h. Limit h goes to 0, f of h0 means h square sin 1 over h square divided by h. Just cancel this, but then this value would be h sin 1 over h square. And this value is goes to 0. Therefore, similarly, if we check fy, then this value limit k goes to 0, f of 0k minus f of 0 over k. F of 0k means, just put the value, this value would be limit k goes to 0, k square sin 1 over k square, and this value f of 0 means 0 over k, this value k, so this value is goes to 0. Therefore, partial derivative with respect to x and partial derivative with respect to y, this is exist. Now I will see the differentiability. For differentiability, limit a square goes to 0, f of hk minus x fx minus k f of y divided by square root of h square plus k square. And f of hk means limit hk goes to 0, h square plus k square sin 1 over h square plus k square minus h times 0 minus k times 0 divided by square root of h square plus k square. And this value is limit hk tends to 0, square root of h square plus k square sin 1 over h square plus k square. Now to find the limit, just replace it by polar form. Limit r goes to 0, square root of r sin 1 over r square. Since this is the bounded part, so this value always goes to 0. So the function is differentiable. That means function is differentiable at the point 0, 0. Not only 0, 0, actually function is differentiable. Next, see the option. Function is differentiable at 0, 0. This is right option. F is not continuous at 0, 0. This is wrong. F is continuous but not differentiable at 0. This is wrong. And option 1, the partial derivative with respect to x and with respect to y exists as 0, 0. But unbounded in a neighborhood of 0, 0. Is this option is true? I hope my all viewers have understood. Here I have seen few minutes ago partial derivative exists as 0, 0. But is the function is unbounded in the neighborhood of 0, 0? That means we have limit xy goes to 0, 0 fxy. If this value is finite, then we can tell this function is bounded. To see bounded and unbounded, put y equal to mx. Then this limit would be limit x goes to 0, x square plus m square x square sin 1 over x square plus m square x square. And we all of us know sin x means x plus x cube x to the power 5. x to the power 5 over 5 factorial, so on. So this value would be 1 over x square plus m square, 1 over 3 factorial x square plus m square to the power cube, so on. Here would be cancelled. That means this value would be limit x goes to 0, 1 plus 1 over 3 factorial 1 over x square plus m square x square to the power whole square, so on. And this term, as x goes to 0, these terms goes to infinity. What this type, this look like such type, so this is goes to infinity. Since the value is not finite, so the function is unbounded near 0. That means option 1 also right option. The partial derivative with respect to x and a partial derivative with respect to y exist at 0, 0, but unbounded in any neighborhood of 0, 0. Okay. Next example, f of xy equal to x cube over x square plus y square when xy not equal to 0, 0 and 0 when xy equal to 0, 0. Then at the point 0, 0, fx and f of y does not exist. This is the first option. And second option, f of x and f of y exist and are equal, the value is equal. And third option, the directional derivative exists along any straight line, or fourth option, f is differentiable. At first, check continuity, because differentiability means function always continuous, but if the continuity break, then the function is not differentiable. We cannot apply these rules because when a, b, c, d greater than 0, strictly greater than 0, then we can apply these rules. Here, y is 0. Since b does not equal to strictly greater than 0, so we cannot apply these rules. Check continuity, just apply the polar form, because here x square plus y square. So I hope my all viewers have understood. If we put the polar form, then this is the easiest method. Consider x equal to r cos theta, y equal to r sin theta. Then it would be reduces r cube cos cube theta divided by r square. So this value is r cos cube theta. So limit r goes to 0, this value tends to 0. So obviously the function is continuous. Next I will see the partial derivative. Then I will see about differentiability, directional derivative. Partial derivative with respect to x, this value is limit h goes to 0, h cube over h cube, this value is 1. And partial derivative with respect to y at the point 0, 0 is limit k goes to 0, f of 0k minus f of 0, 0 divided by k, and this value is equal to, let's put the value f of 0k, this value is equal to 0. So fx and f of y exist and are equal. This is wrong option. Both exist but does not equal. So this is the wrong option. Here indicate fx and f of y does not exist. This is also wrong option. Fx and f of y exist but not, the value is not equal. Now I will see about differentiability. Obviously the function is differentiable in all point. Only I will check the differentiable at the point 0, 0. Check the differentiability at 0, 0. This value would be limit h goes to 0, k goes to 0, f of hk minus f of 0, 0 minus h fx minus k f of y divided by square root of h square plus k square. And f of hk means obviously h cube divided by h square plus k square. And h fx means the value is 1 and kfy is 0 divided by square root of h square plus k. This value is minus h k square divided by h square plus k square to the power 3 over 2. Now k, put k equal to ms. Then this value would be minus m h cube divided by h square plus m square h square to the power 3 over 2. And this value would be, limit h goes to 0, this value would be minus m divided by 1 plus m square to the power 3. Limit h goes to 0. And for different value of m, here the limiting value would be different. So, since the limit depends on m, so this limit does not exist. Since the limit does not exist, that means function is not differentiable. So function is differentiable, this is wrong option. And option 3, the directional derivative exists along any direction, along the straight line. Is it true? For this, I will see the directional derivative at the point 0. F of acu1 comma acu2 minus f of 0 0, since f of xy means x cube divided by x square plus y square. Just put the value, then this would be limit h goes to 0, h cube u1 cube divided by h square u1 square plus h square u2 square. So this value would be u1 cube divided by u1 square plus u2 square. So directional derivative along the direction u1, u2 always exist. So directional derivative exists along any direction at 0 0, and since otherwise in all point without 0 0 the function is differentiable, so obviously all directional derivative exist other point or directional derivative exists along any straight line. This is be the right option, because directional derivative exists any direction, so along the any straight line, this is also obviously right option. I hope my all viewers have understood this question and this option. Okay. Today I will stop here. In my next video, I will discuss this type of concept again, because this I have told you many times, this type of concept actually very important for higher study. See you soon. Stay safe and stay positive always, and don't forget to subscribe my channel for more videos. Thank you so much.